core issue with overloading extension cords stems from heat buildup. Every additional cord and connected device introduces more resistance into the circuit, and this increased resistance directly contributes to a rise in temperature. Some extension cords are designed with a built-in thermal fuse, which is a safety mechanism that automatically cuts off the power supply to the cord if it detects excessive heat. This is intended to prevent the cord from overheating to the point of causing a fire. A practical way to determine if you are overloading an extension cord or a receptacle is to physically check their temperature. If the extension cord or the receptacle feels warm or hot to the touch, this is a clear indication that too many devices are plugged into the circuit. This overheating occurs because the current flowing through the cord is higher than what it is designed to handle, causing the conductors inside to heat up. Most extension cord manufacturers include a label on the cord that specifies the maximum allowable amperage. This rating is a crucial guideline for safe usage. It indicates the highest amount of electrical current a cord can safely carry without overheating. It is important to use this amperage rating as a starting point for determining how many devices can be safely connected to the cord. Even if the total amperage draw of the devices plugged into the extension cord appears to be within the cord's rated capacity, it is still possible to overload the cord. This is because the increased resistance along the length of the extension cord can lead to a higher actual amperage draw than expected. The resistance increases as the cord heats up, further exacerbating the problem. In summary, a key indicator of an overloaded extension cord is its temperature. If the cord or the receptacle it is plugged into feels warm to the touch, it is a sign that too many devices are connected and the risk of overheating and potentially causing a fire is elevated. It is essential to reduce the load by unplugging some devices until the cord and receptacle are no longer warm. The National Electrical Code, or NEC, provides guidelines and standards for electrical installations to ensure safety. While it might not explicitly state that using too many devices on an extension cord is a direct violation, it addresses the broader issues of overcurrent protection and proper use of extension cords. Several sections of the NEC relate to the safe use of extension cords and preventing overloads, including Article 240, which covers overcurrent protection. This article requires that electrical circuits be protected by fuses or circuit breakers that will interrupt the flow of electricity if the current exceeds the safe ampacity of the wires. This is to prevent overheating and potential fires. Article 310.15 and related tables provide guidance on the ampacity or current carrying capacity of various types of conductors. These tables help determine the appropriate size of wires and cables for different applications to prevent overheating. Article 400 deals with flexible cords and cables, including extension cords. It specifies the types of cords that are suitable for different uses and provides guidelines for their proper installation and use. It also emphasizes that flexible cords should not be used as a substitute for the fixed wiring of a building. Article 590 covers temporary installations, which often involve the use of extension cords. It sets requirements for the safe use of temporary wiring, including proper overcurrent protection and grounding. While the NEC does not offer a specific formula for calculating the exact number of devices that can be safely plugged into an extension cord, it emphasizes the importance of not exceeding the cord's ampacity rating and avoiding conditions that could lead to overheating. The NEC provides requirements for overcurrent protection to protect the extension cord. When discussing electrical safety and extension cords, it is important to understand several key electrical concepts, including ampacity, which is the maximum amount of electrical current a conductor or device can carry continuously without exceeding its temperature rating. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of electricity when the current exceeds a safe level, preventing overheating and potential fires. Resistance is the opposition to the flow of electrical current in a circuit. Higher resistance leads to increased heat generation when current flows through it. Voltage drop is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or not at all. Understanding these concepts helps in assessing the risks associated with overloading extension cords and taking appropriate safety measures. To determine how many devices are too much for an extension cord, several factors need to be considered. Firstly, check the ampacity rating of the extension cord. This is usually printed on the cord's jacket or on a label attached to the cord. The ampacity rating indicates the maximum amount of current the cord can safely handle. Secondly, determine the amperage draw of each device that will be plugged into the extension cord. This information can usually be found on the device's nameplate or in its user manual. Add up the amperage draw of all the devices that will be connected to the extension cord. The total amperage should not exceed the cord's ampacity rating. Consider the length of the extension cord. Longer cords have higher resistance, which can lead to voltage drop and increased heat generation. If using a long extension cord, it may be necessary to reduce the number of devices plugged into it. Check the temperature of the extension cord and the receptacle it is plugged into. If they feel warm or hot to the touch, it is a sign that the cord is overloaded and the number of devices needs to be reduced. As an example, let's consider a 15 amp extension cord. If you want to plug in several devices, you would need to check the amperage of each. A lamp might draw 1 amp while a television could draw 2 amps and a space heater might draw 12. If you plug all of these into the 15 amp extension cord, the total draw would be 1 plus 2 plus 12, which equals 15 amps. This is right at the limit of the cord's capacity. However, if the space heater has a higher amperage draw, such as 13 or 14 amps, then the total would exceed the 15 amp limit of the extension cord and it would be overloaded. In addition to amperage, wattage is another important factor. Wattage represents the amount of electrical power a device consumes. To determine the wattage of a device, look for the wattage rating on the device's nameplate or in its user manual. If the wattage is not listed but the voltage and amperage are, you can calculate the wattage by multiplying the voltage by the amperage. The standard voltage in most residential outlets is 120 volts. For example, if a device is rated at 120 volts and 5 amps, its wattage would be 120 volts times 5 amps equals 600 watts. Extension cords also have a maximum wattage rating, which indicates the highest amount of power they can safely handle. This rating is usually found on the cord's label. To determine how many devices can be safely plugged into an extension cord, you need to calculate the total wattage of all the devices and ensure that it does not exceed the cord's maximum wattage rating. For example, if an extension cord has a maximum wattage rating of 1800 watts and you want to plug in several devices, you would need to calculate the wattage of each device and add them up. If the total wattage exceeds 1800 watts, then you would need to reduce the number of devices or use a higher rated extension cord. When using multiple extension cords connected in series, it is important to consider the cumulative effect on resistance and voltage drop. Connecting extension cords in series increases the total length of the circuit, which in turn increases the resistance. This increased resistance can lead to a greater voltage drop at the end of the circuit, which can cause appliances to operate inefficiently or not at all. Additionally, the increased resistance can cause the cords to heat up more, increasing the risk of fire. To minimize these risks, it is generally recommended to avoid connecting multiple extension cords in series. If a longer cord is needed, it is better to use a single extension cord of the required length rather than connecting several shorter cords together. If connecting multiple cords is unavoidable, it is important to use heavy-duty cords with a sufficient ampacity rating to handle the total load. Also, regularly check the cords and connections for any signs of overheating. There are several common misconceptions about extension cords that can lead to unsafe practices. One misconception is that it is safe to use an extension cord indefinitely as a substitute for permanent wiring. Extension cords are intended for temporary use only. Prolonged use can cause the cord to deteriorate and increase the risk of fire. Another misconception is that all extension cords are the same and can be used for any purpose. Extension cords come in different gauges and ampacity ratings. Using the wrong type of cord for a particular application can lead to overloading and overheating. Another misconception is that it is safe to cover an extension cord with rug or furniture. Covering an extension cord can trap heat and cause the cord to overheat, potentially leading to a fire. It is important to keep extension cords exposed to the air to allow for proper ventilation. Many people believe that if an extension cord has a surge protector, it is safe to plug in as many devices as possible. While surge protectors can protect devices from voltage spikes, they do not prevent overloading. It is still important to ensure that the total amperage draw of all devices plugged into the extension cord does not exceed the cord's ampacity rating. There are several best practices for using extension cords safely. Firstly, always inspect extension cords for damage before use. Check for frayed wires, cracked insulation, and loose connections. Damaged cords should be replaced immediately. Secondly, use the right type of extension cord for the application. Use heavy-duty cords for high-powered devices and outdoor-rated cords for outdoor use. Thirdly, avoid overloading extension cords. Do not exceed the cord's ampacity rating and avoid plugging too many devices into a single cord. Fourthly, do not run extension cords under rugs or furniture. Keep cords exposed to the air for ventilation. Fifthly, unplug extension cords when not in use. This can help prevent overheating and conserve energy. Sixthly, do not use extension cords as a permanent wiring solution. If permanent wiring is needed, have it installed by a qualified electrician. Seventhly, use extension cords with built-in safety features such as surge protectors and thermal fuses. Surge protectors can protect devices from voltage spikes, while thermal fuses can prevent overheating. Eighthly, regularly check extension cords and connections for signs of overheating. If a cord or connection feels warm to the touch, reduce the load or replace the cord. By following these best practices, you can significantly reduce the risk of fire and electrical hazards associated with extension cords.